All right, we're back, and we've got multiple sunspot groups. Welcome to the daily space weather here at the Smash News Network, least busted name in news. Here's some SDO imagery of the closest star. Shout out to all you stargazers. We got a brand new sunspot group growing here. It's beta class, another one rising. Two groups will get named today. Here they are. This one's pretty big, although not so complex. This one is pretty spontaneous. And beta class already. The likelihood of flares has gone up. We've seen a flare nearly of C class already. Let's get that going. This is a composite view. We've added 94 angstroms to the 171 angstroms there. Two different very specific bands of the ultraviolet light spectrum. So yeah, the place to keep an eye on is this spot right here. Although there is some apparent possibility of flares for this as well. So I believe that larger group is only an alpha class sunspot at the moment. Anyway, there's the colorized magnetogram, and yeah, you can see the sudden formation of that. That's the most likely spot to see a significant solar flare at the moment would be from this sunspot. And we may see another group forming up here as well. We see some activity here in terms of magnetic organization. Let's zoom out to the full view for the SDO colorized magnetogram. And let's blast through some more data like the radio flux, which is going to be coming up promptly. I think it's still only at 76 here. And yeah, it looks like 76 for the radio flux. There you go. No geomagnetic unrest or storms forecasted by NOAA according to the Space Weather Enthusiast dashboard. Still an intensification expected here on the 14th from a coronal hole wind stream. Some seismicity kicking off here as we saw a 6.5 magnitude quake happen way down there in the southern Pacific Ocean there near Macquarie Island, a very desolate portion of the planet. South of New Zealand and Australia and Tasmania. Not a lot of civilization in that area, let's say. Anyway, that was a 6.5 magnitude quake, and it came in just a little while before we made the video, which was originally streamed live to Twitch at twitch.tv/smAsho. So let's just scroll up the list here. There's a very deep quake near Fiji at a 4.3 magnitude. If that happened at the surface, that would be like a 6 magnitude quake. A 5.1 at the South Sandwich Islands as that region continues to shake. Chile saw 5.7. 5.6 at Timor-Leste. Iran, a 4.8 at Iran. Deep quake at Afghanistan at a 4.1 magnitude. Two Japan quakes, a 4.5 and a 4.9. Very deep quake at Timor-Leste, 4.4 at 535 kilometers. Some quakes around Alaska. So a little bit of an uptick there in seismicity, folks. Two more Japanese quakes there, a 5.2 and a 5.0. And then there's this 6.5. It came in at 8:58 Universal Time this morning. So just while we were doing show prep. Large quake there. And I don't see any tsunami warnings or anything associated with that. Let's see what volcanic activity is happening. Before we get back to space data, let's blast through volcanoes. La Palma still producing an 8,000-foot ash plume. Semeru, 14,000-foot ash plume. That has been the most active volcano in the past week or two. Fuego exploding, flight level 150. Over the Guatemalan volcano Fuego. Sangay, volcanic ash not observed in satellite. Revenador continues to explode. 15,000-foot ash plume from Revenador. Unable to detect Sabancaya and Nevados de Chilean. They're located in Peru for Sabancaya and central Chile for Nevados de Chilean. Please don't pole vault the caldera, which is our featured product. We've got the socks. They're very nice and comfortable. The print quality is spectacular. Perhaps pick up a Do Not Pole Vault the Caldera floor pillow for your favorite pal at Christmas with the important public service message. No matter how athletic you are, folks, don't pole vault volcanic calderas. It could be unhealthful, and we need the views on YouTube, so perhaps pick up a Do Not Pole Vault the Caldera miniskirt, one of our house favorites. And this is, I think, our number 4 bestseller. You can find links to all of the products, as well as at smAsho.com, our homepage. Do not pole vault the caldera, folks. Tell your friends and foes not to pole vault the caldera. This important public service message brought to you at massive personal risk and expense by smAsho.com. So help us pay the bills by becoming a member of the Smash team. Perhaps we've replaced Patreon with something superior. So check it out, smAsho.com/Smash team. Free posts going up through the holiday season. So through New Year's Eve, we will continue to put up free posts thanks to all of our paying subscribers. Please consider joining at the gold or perhaps the silver level. smAsho.com/Smash team. Links on the homepage to that, as well as to the merch. Let's get back to the weather in space. The GOES magnetometer and some Gong 2 data is next. It's quite important data, really. Pretty definitive. And there's the GOES magnetometers over the past 3 days. Let's look at the current sheet. And there is likely to be a North Pole current sheet coming. At the moment, none in sight. Earth currently in a South Pole current sheet shown here in red. As the plasma orients to the fields. Next, the line of sight plot. Keep in mind this data is an hour and 24 minutes old and can suddenly change, the way we saw sunspots suddenly appear. Why do sunspots suddenly appear? When magnetic fields are organized there. All right, so here's a line of sight coronal hole plot, and we see a series of coronal holes there in the southern hemisphere. We can expect some geo effects from these. Probably nothing major, but here is the SDO imagery in 193 angstroms, which is a great wavelength for coronal holes. Again, they're all South Pole oriented. They're not really trans-equatorial. As cycle 25 progresses, kind of slowly. Likelihood of flares has gone up, like I said, especially from this beta class sunspot down here. It'll get numbered today. There will be 2 numbered sunspot groups, most likely. And we did see a nearly C-class flare here at 5:40 Universal Time. 5:40 this morning on 12/12/2021. No spikes in the proton flux, no surprises to our regular viewers there. Let's go to the real-time solar wind here. Pretty uneventful. Solar wind density just under 10 protons per cubic centimeter. Solar wind speed 303 kilometers a second. It's been pretty consistent over the past 24, reaching all the way down into the 280s. A very slow solar wind speed. So we will see a large change when we see a high-speed coronal hole wind stream come in a couple of days, about 2 days here. KP index at 0. Very calm geomagnetic conditions with that slow solar wind. Here's a model of what the magnetic moment likely looks like. It's known as the Space Weather Modeling Framework. And this is what happens when protons form into field-aligned currents and so on. It's 4 hours of data. Pretty homogeneous magnetohydrodynamic pressure there over the past 4 hours. Here's 4 hours of ground magnetic perturbations. This is magnetic flux density, nanotesla, at the ground level. The last one was the magnetic moment from space to about 12 Earth diameters. This is on the ground level. Changes to Earth's B field at the surface of the planet. Again, 4 hours of data, no big changes happening there. If you're wondering where objects are in the solar system, hopefully it's not because you're frightened of them. I know there are some silly videos on YouTube about scary, spooky planets and so on. Don't worry, folks. Jupiter and Saturn aren't going to kill you. Let's do a forecast. And there's where things will be in a week. Full moon coming around the 18th or 19th of December. As Christmas rapidly arrives. Next, a star chart. This is what's going on above my head if you want to make your own for your location. Head to in-the-sky.org. We're not paid to say it. We're just letting you know someplace where you can make yourself a star chart. This is the all-sky chart, I believe. And we've got the ecliptic and the galactic plane in there. Those are the yellow and blue lines, respectively. And let's take a look at our coronal mass ejection watch, which continues. One's going to happen soon, folks, believe it or not. Sometimes these things take a couple of days, a few days. Here's the view from stereo A on the left and Lagrange point 1, LASCO C3 on the right. There you go. Some of this plasma will eject soon, at which point we'll switch our watch to a warning. We've also got Mercury here. Some of this could collapse as well, but some of that is going to eject. And if you don't believe me, just continue to watch the channel. We'll cover it. As well as cosmology subjects. Let's blast through some more. We've got a random object. It's, quote, random and quote object number 45, which I don't know anything about. I just looked it up this morning. It's quasar PKS 0116-219. And when you're streaming live, there's nothing you can do except react appropriately. So let me just check the life of the stream. Everything looks good, and thanks for leaving comments 1 audio. I don't know what he's talking about, but yeah, I don't know what's sick and anemic. The fields, I think they're fine. Anyway, here is the X-ray output of this quasar. PKS 0116-219. As you can see from the historic graph up here, that's about a 16-year graph. It's a pretty consistent X-ray source. A distant galaxy, an active galactic nucleus known as a quasar. It's the kind of situation where if the galaxy was oriented like this, you would be off in this direction viewing its jet, like if it had a central jet from its galactic core, and that tends to make them look very bright. Quasars, distant galaxies with a specific orientation with respect to us, the viewer, here on Earth. Anyway, there's a 30-day graph of it, and let's take a look at those. Those were X-rays, by the way. Let's see what kind of imagery we can get here on Aladdin Light. So this is a visible image, I believe. Just scroll down the list. Again, we are streaming live at the moment, so bear with me a quick moment here, folks. And there's that quasar looking pretty dim. Again, likely a distant galaxy. Let's take a look at it in X-ray. See what we can find. Does it show up in ultraviolet? Yes, it does. So it's a good ultraviolet source. There it is on the Galix. Let's see what the most... There's the color composite. A little bit better imagery there. So it does have a UV signature. And if you look at the CDS portal, it does have photometric points, so it'll tell you what parts of the spectrum it's bright in. There are the photometric points. Quite a bit of articles on this quasar. And quasars are interesting because of their orientation primarily. Let's take a look at it in optical. There's a great view from the high-resolution Pan-STARRS survey, a great view of that distant galaxy. PKS 0116-219, a quasar, number 45 at the Neil Gehrels on the transients page if you want to go check it out yourself. That's what it looks like invisible. And let's take a look at some other interesting objects here. It's the astronomy picture of the day. We're going to do a slow roll, as there is quite the spectacular globular cluster. Hamming it up. Just great imagery there. Very high resolution. If you want a new desktop, this is a pretty good one. If you like action desktops. As we've also got a great comet nucleus. And I'm doing the slow crawl for all you folks viewing this on a big screen. Spectacular imagery there. And that is of Comet Leonard and star cluster M3. Yes, the Messier third object in the Messier catalog. M3, the globular cluster. Gravitationally bound, basically miniature elliptical galaxies within the galaxy. The astronomy picture of the day, apod.nasa.gov, and let's close out the cosmology segment with cosmic ray flux. Check it out, the Apatity neutron monitor just saw a spike here. Levels dropped, and then levels rose. Just in the past day, actually. That's a 30-day graph at Apatity. And over the past 30 days, it's a slight uptick, actually, in cosmic ray flux at Apatity. Barentsburg, a downtick at Barentsburg. Some missing data there, so let's just leave that alone and go farther south to Athens, Greece. See what's going on at the Athens neutron monitor. Please, there we go. And there's the Athens neutron monitor. And at Athens, it's pretty flat over the past 30 days there. Whoops. And we'll go farther south to Mexico City. There's Mexico City. Slight downtick there at Mexico City over the past 30. And let's go back north to Oulu, Finland. These are in alphabetical order, folks. Apatity, Athens, Mexico, Oulu. Anyway, there's Oulu. And we use only reliable cosmic ray monitors, not ones that show a lot of funky data. These all seem fairly believable. And Oulu is seeing a downtick here over the past 30 days, a slight downtick. Let's check Antarctica. Some wild swings there in the Antarctican monitors. And no real surprise there, as the poles experience a completely different cosmic ray environment than the equatorial regions of the planet. DOMB and DOMC Antarctica there showing some larger swings, both up and down. That's today's cosmology segment. Cosmic rays. You'll find them more and more interesting the more you learn about them. Let's see what's going on with charging hazards. Actually, let me check the life of the stream here once again. And everything looks great. Thanks again for leaving comments. Robert. Shout out to Robert. No charging hazards at the moment. Here's the electron flux over the past year, and we're just in moderate levels here. A bit of a cratering happening. So kind of low levels of electron flux actually at the moment. Not axially, actually. And here's the forecast model. Expecting a continued downtick here. I would tend to agree, as again there is a coronal hole wind stream on the way. Next we'll show you the total electron content forecast, which helps to forecast GPS errors, for example. As your GPS must communicate through a lot of electrons. And that causes signal refraction. I'll let it play through a second time here, as we tend to see more GPS errors when we see low levels of electron flux. Nothing too crazy going on there. Let's look at the ionosphere next. We'll show you the ionogram and the anomalygram for the F layer, located at about 300 kilometers of altitude. Here is your ionogram animation. And here is your anomalygram. This is anomaly in megahertz from the 30-day median. Anomaly in megahertz from the 30-day median. Quite a lot of low-frequency anomalies happening here, and some wild swings over the South Atlantic anomaly, located right about here where my pointer is. You're seeing some shifts there from high to low-frequency anomaly. The scale there is 6 megahertz. So looking at the latest image, this is the ionogram showing megahertz, millions of vibrations per second. And that's at 10:45 universal time. There's the anomalygram for that moment. And you can see a low-frequency anomaly right there near the Drake Passage. One of the crazier places on the planet is that Drake's Passage. All right, let's do bonus features. It's about that time. Looking at Cerro Tololo, it's about that time. Oh, no, we've got old data there. We've got old data all around the horn here. Let's go to El Teide. It's still 7 hours old at El Teide, Spain. Hopefully no issues going on. Anyway, there's the ground-based observatory at El Teide, Spain. It's pretty old, so let's move on. Here's some imagery that we got from Cerro Tololo this morning. I don't know if maybe they had an earthquake, I'm not sure. Anyway, here's the GOES 16 SUVI. And we were thinking about making a video about this prominence, but with new sunspots forming and so on, it's just not in the cards at the moment. Great current imagery there from the GOES 16 SUVI. It auto-refreshes, by the way, if you want that on your desktop all day long. It's pretty spectacular. So let's see if that's still beta class. Certainly looks like it to me. It's got some North Pole umbre there, as these are north, and this one here is south. Making it a beta class sunspot. That one down there I don't think is beta class. I think that is an alpha class sunspot. Looks alpha class to me. If you disagree, leave us a comment and let us know. Again, this is the one to watch because of its field complexity. It's still small, but we'll be keeping an eye on it. And when I say ion, pardon the pun, we'll close the video out with the ionized helium view here from the Solar Dynamics Observatory. 304 angstroms, great at showing all those prominences. Anyway, thanks once again for tuning in. If you're new to the channel, press like, subscribe, share, etc. Tell your friends and foes about us, and may that solar wind be at your back. Opinions expressed in this video, not necessarily the opinions of Smash News Network, least busted. Name it news.